Welcome to a somewhat chilly Haxby shed. I'd like to show you a few things that I got from the Autojumble recently, including a couple of very useful electric motors. I hope you find them interesting. I've been to the Autojumble again. Now, perhaps not everybody knows what an Autojumble is. It's basically a meet where you buy and sell parts for cars or motorbikes, or anything vaguely automotive. But actually the one that we have near us, which is about 8 miles away in Rougheth, started out like that, but it's changed quite a lot now, and you can get anything there from household products, perhaps cleaning products. A lot of the stalls are selling tools, and some of the stalls are selling machining parts, like you can see here. I should think about 10 or 15% of the stalls still sell parts for old motorbikes and a little bit for cars. I'll put in a bit of video so you can see what it is, what it's like. Anyway, I bought a couple of drills, 9/16, 11/16. It's always good to have the imperial sizes because they're often sitting in between the metric sizes. A rotor broach, 50, it will cut 50 deep. It's 40 millimeters diameter. So I paid £2 each for these. I paid £15 for this. Now it has been used, but not very much. And if I was to buy that new on eBay, probably £55. So £15 is all right. I picked up this fairly heavy Machinist Jack for £5, which I thought was, okay. Can't say I really need one, but it was there, and for £5 I wasn't going to turn it down. Now then, tonight's star prizes are this brake motor. So this is the spinny bit, this is the brakey bit. You can see that it's got a chain gear on it. It's 15 watts, and that cost me £5. It's single phase. Now there were several Panasonic motors available, but I went for this one because the Panasonic motors of a similar style had more wires, so I wasn't quite sure what they were all for. And this one has a wiring diagram on the back. So I'm pretty sure I can wire this one up. And the other great prize was this. Oh. Gear motor. I don't know quite what the reduction is going to be. It's 3-phase, 60 watt. So I'll need an inverter to drive it. £10. £10. Now have a look on eBay for these. £100, £150 perhaps. That's what people are trying to sell them for. £10. It's a Flender, if you know it. I didn't know it, but they seem to be a well-respected make of industrial motors. So, as usual, it's buy it and then think about what I might use it for. But actually I have got something in mind because I'm working towards making a welding rotator. So pros and cons for using, this one or this one. This perhaps has the most potential, but it's large and it's heavy, and it will need an inverter to drive it. Now, I don't have an inverter available. I'll have to get one. The cheapest one I can find on eBay is about £45, £50. Now, that doesn't sound a lot, does it? But when you've only paid £10 for the motor, then it does sound a lot that way. So I'll be looking for something as cheap as I can possibly find to drive this. In the meantime, I may try it out on one of the inverters that I have, perhaps the one on my shaper. I'll just wire this in and try it out. Now, when it comes to making the welding rotator, I've got a chuck already, which I might feature in a different video, perhaps come out before this video. That could go onto there. So that could be the sort of basis. Anyway, I won't say too much about that because that's all speculative, let's say. But what I'm going to do is I'm going to see if I can wire this up and get this working. It requires a 1.5 microfarad capacitor. I might have one in one of my tins somewhere. Maybe I just say something about this though in addition. I don't have a holder for here. I did price up a Morse Taper 3 holder and the guy wanted 30 quid. That was at the Autojumble. Well, that's too much. You can buy them new for about 45, I think, on eBay. So I'll be on the lookout for a holder, a Morse Taper 3 holder. I also need the pin that goes in the middle. But, you know, one step at a time, really. Okay, let's see if we can get this going now. To begin with, I've just wired up the brake circuit. So I've put it straight across the mains, but I've put the earth on for good measure. I wanted to test the brake circuit first, one, because it's easiest, but also if the brake circuit has gone open circuit and it's not working, then the motor might not be much use, although I'm sure I could take the brake off. So let's just take this casing off. I don't know if we'll see it working, but I have tested it and it does work. Let's see what happens. You should at least be able to hear it click. Yes, there it is. Let me zoom in and show you. Watch that plate when I turn the power on. So that plate is spring loaded by a spring here, pushing it towards this side, and then the electromagnet on this coil here, these are the wires for the coil anyway, they pull this plate against its own spring away from this end of the motor. Now normally it would be switched so that when you turn the motor on, this plate's pulled back and takes the brake off, and when you turn the motor off, this plate drops back onto the end of the motor armature and brakes it. Well, we don't need to do that just for this test. Now we've tested the brake, we can move on to test the motor itself. I've got this capacitor in my junk box. Let's see if you can see it there. It's 3 microfarads, so it's double what I actually need, but it'll do for this test. They're only peanuts to buy these, a pound or something. So, you know, if this works okay, I'll just buy one of the right size later on. All wired up now. Let's give it a test. Moment of truth. Ah, lovely and smooth actually. Now I need to see how fast this is spinning. I'll just time it over half a minute and count the turns. Okay, 30 seconds, stop. That's about 15 turns, so it's doing about 30 RPM. Now we've got this one going, let's see what we can do with this one. Now I'm going to have to use an inverter to drive this. It's a 3-phase motor, 60 watts. I'm actually going to wire it up to the inverter on my shaper. It's worth the trouble because I don't want to pay for an inverter for this to find it doesn't work. So that's what I'm going to do next. I need to check the voltage strapping on this motor. And you can see there, this connection block, it's got 3 straps on it. Now when I first opened this up, because I've done a bit of work off camera, these 3 straps were across here. Well, that would be wired for high voltage, 415 volts here, and I need this wired for low voltage because I'm running my inverter from a 240 volt supply. So I shifted the 3 straps which were across here, 2 on one side and 1 over here, around like this, and now this is set for delta configuration instead of Y configuration, and it'll run off the low voltage. The other thing I've done is I've just put on a tail just to make it easier to connect up. So you can see there I've pulled the inverter out from underneath the shaper. Okay, it's all wired up and we'll give it a try. It starts up slowly on the inverter. I think the ramp up I've got set to 6 seconds. So that's why it made that slow start. Just off camera there, I timed that, and that's at about 20 RPM. Now that's about right if I was to mount the chuck directly onto that sprocket there, because the welding rotators that I've seen that I might consider buying, which cost about £200 by the way, they've got a speed range of between 20 RPM and 2 RPM. So I need to see if I can get this down to 2 RPM, and to do that I need to make an adjustment to the settings on my inverter. Right, I've changed that parameter now right down to 5%, which should give us a minimum frequency of 2.5 Hertz, or by my calculation 1 RPM. So let's see what we can get down to. I've no idea how this is going to work. It might be really juddery down at that frequency. I guess it depends how good the inverter is and a few other things. So we'll start at 50 Hertz, which will be about the 20 RPM. And I've got a little thing to turn here to get that down. And I can see the setting as it comes down. I can see the frequency coming down on the inverter. So that's about 20 Hertz. That's 2.5 Hertz. So can you just see that sprocket turning? So that would be 1 RPM. So actually this motor would be perfect for a direct drive welding rotator with an inverter. Let's turn it back up again. Well, I think that brings us to the end of this. I hope it was useful to you. Thank you for watching Haxby Shed. This is the sort of thing you get at the Autojumble. Things you didn't want to buy, but you couldn't resist. 60 quid, but it's not me, it's my son-in-law. Anyway, that's it for today.